Mhm. Dokie. Okie dokie. Thanks for the heads up. Today's the 16th of January. Okie dokie. So the goal for today is to learn how to look at tables of X's and Y's and identify whether the points in the table represent a linear relationship, a linear function, or if it's non-linear. Okay, we're not going to talk about exponential functions yet. We're just today going to learn to differentiate between, is it linear or is it not linear? Now, one thing I'm not going to ask you to do, today's assignment won't ask this of you either, is to identify a linear function based on points on a graph. And don't write this part down, but like, I'm not going to insult your intelligence by asking you if that's a linear function. Obviously, it's not. The root word of linear is, of course, line. And so you can tell that a function is linear if it forms a straight line. And when we don't have a graph to look at, then the only way we can really identify whether or not something is linear is by its slope. So like if you thought about it, if I gave you a graph, like you could find the slope between these 2 points and say that maybe it's like, I don't know, like 1/3 or something like that, right? So maybe the slope, bless you, between those 2 points is 1/3. And hey, maybe the slope between these 2 points is 1/3 or something like that. But you would agree, obviously, duh, that the slope between like these 2 points is more like maybe 1, right? So in order to identify if a function is linear or nonlinear, when we don't have the dots to look at, we have to rely on our knowledge of how to find slope or rate of change. So that's what we're going to do today. And I'll teach this whole lesson pretty much on Delta Math. Like you won't see much of me writing on this surface here anymore. So I'm going to head over to Delta and just bring up sample problems. And as always, it's kind of hard to take notes when I do that because I have a little, it's already on my screen, whereas it's hard to get it into your notes. So take notes as you see fit, as what you think is appropriate, however you want to do that. Let's see. So this is what you're going to see. They won't all look like format wise, they won't all look like this. But the question says which table of values represents a linear function? And I believe sometimes it might also say which of these is not a linear function. So just pay attention to the verbiage. Questions sometimes come in from different directions. You got to, am I looking for the one that is or the one that's not? In this case, we're looking for the one that is. We want it to represent a linear function. And so there's a couple ways. I'm going to teach you the very proper way to do this first. And then there is a little bit of an easier way that doesn't always work, but it's quicker if you're able to use it. So here it goes. So we're going to check table A first of all to see if A is a linear function. And the way we do this is we think of these as ordered pairs. So like the first point in this table is -1, 5, right? And the second point is 1, 3. You can see that from the X's and Y's. So we're going to talk just logically about slope. Slope is simply this. Slope is change in Y over change in X. You know it as y2 minus y1 over x2 minus x1. But a more concise and like palatable way to say that is just what I have written here. How much does y change divided by how much does x change? So we can approach this in a really logical manner. So here it goes. When you go from the first point to the second point, from here to here, how much does y change? Careful, -2. Thank you for saying negative. So the change there is -2. Now, on the same point, or from the point, from one point to the same second point, follow the other arrow over here. How much does x change? It goes up by 2. It gets +2. And what's -2 divided by 2? -1. So we could say that if we graphed those 2 points on a graph and we counted the rise and run staircase thing between them, they would have a slope of -1. Down 1, right 1 would be the simplified version of that. Good? Now that doesn't mean bupkis. What I have to do now is I have to say, okay, now I have to go and find the slope between the next pair of points. And so we're going to do the same thing. How much does 3 change to become 1? -2. And how much does 1 change to become 4? And I don't mean to insult your intelligence by asking this question, but I have to. Are those rates of change the same? Then A cannot be a linear function right away. And it might take you a while. You may not find it until the third iteration of what we just did instead of the second, but you'll see if it's meant to be a linear function, then the rates of change from each point to the next one will be the same. You follow? Okay, so with A out of the way, let's switch to the next table, that's B. How much does, so I'm going to erase my work over here on the right. I don't need this anymore. So now, from first point to second point, always do your y's first. How much does y change? Yep, it increases by 2, right? So I'm going to put +2. And how much does x change? It increases by 1, and 2 divided by 1 is 2. So we have a rate of change of 2. 2 y's for every x. And now I have to go to the next pair of points. So I'm going to go from here to there. What's -4 up to -2? What's that increase? Again, it's an increase of 2, isn't it? And then what is 4 to 5? An increase of 1. So hey, look, we're on a roll here. Do we have enough yet to say that it's a linear function? We don't, because that's good for those 2 points, or those 3 points. But I got to make sure that all 4 points are in a line. And now the only way I can verify that is by showing now that that relationship holds true between the third and fourth points. How does -2 change to become 0? It increases by 2. This is looking good, right? And how much does 5 change to become 7? And 2 divided by 2 is it a linear function? It is not. So far, so good? Okay. Now let's do this next one. And by process of elimination, we'll know, I mean, after this, we'll know what the answer is, because if it's not this one, it's D. If it is this one, then we're done. So real quickly, 9 to 6 is, it's not 3. It's -3. Really important. It's down 3. It gets 3 smaller, and 3 to 5 is +2, because it goes up 2. All right, let's do the next one. Follow the new red arrows. 6 to 3 is -3. 5 to 7 is, things are looking good. 3 to -1 is down 4. To go from 3 to -1, you have to go 1, 2, 3, 4, because you got to go all the way past 0. So we already know this one's out. So guess what? It's going to be D. Now, I want to show you something neat about this, and this kind of leads into the quicker way to do this. I don't expect you to have to do it this way every time. So listen, there will be problems that are harder than others where using the change in Y over change in X trick is what you, I'm sorry, but sometimes you have to do it that way. But look at D, and I want you to see how obvious it is. Sometimes you'll see it, sometimes you won't. But when you see it, you're like, jackpot. Take a look at my X's. Look at the consistency. Go from there to there, there to there, there to there. What is X doing every time? It's increasing by 3, right? And then look at your Y's and see, can they follow a consistent pattern too? Up by 3, up by 3, up by 3. The answer is D. Neat, right? So sometimes you don't have to do all the math. Like you don't have to go one by one. You can sometimes eyeball the whole table and say, and look, I could have even done the shortcut method on like table B. Let's go back to table B. Look at the beauty and consistency in the Y's. Look at that. Up 2, up 2, up 2, right? Isn't that sweet? Up 2 every time. But then look at the X's. Up 1, up 1, up 2. That lack of consistency. If one side of the table holds a consistent pattern and one doesn't, that's a good sign that you're out. You can see it again over here. Look at your X's. Down here on C. Up 2, up 2, up 2. Beautiful. Down 3. down 3, down 4. See, not every problem has to take 5 minutes. You can eyeball them a lot of the time. Okay, let's do another one. So anyways, on that one, what did we say? We're going to pick D, right? So let's go pick D. And again, sometimes it will say which one is not. Let's go find one that. By the way, it can also look like this, right? Let's do one that's in this format. So let's look at A. What pattern do you see in the X's? Go across all the points in A. Tell me, what do you see when you go from X, 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 X? What do you see? So the X's go up by 3. That's consistency. Let's see if we can find some consistency with the Y's. Do you see any consistency with the Y's? What does that to that do? Up 3. Going from -8 to -5 is upwards. So you're going up 3. Go from -5 to -2. What's that? Up 3. Go from -2 to 1. What's that? We already found our winner. I don't even have to check B, C, and D because there's no option for it to be more than 1. It says which one could represent a linear function. We just proved it's got to be A because the Y's all go +3, +3, +3. The X's have their own pattern. So we're going to just pick A. Let's do another one. Can we find one that does not? Maybe they all say positive. I thought some of them were in the negatory, but nope. Doesn't look like it. Let's do another one. You guys feel like you got this? Okay. How about, could A be a linear function? Why not? What about them? What do the X's do, first of all? X's go +3, +3, +3. That's looking good. What do the Y's do? -4, -3. To go from 2 to -1, you have to take away 3. So -4, -3, -4. A is not a linear function. Could it be B? This is one of the ones I was talking about that's way more difficult. So this is one where you might, let's go see if we can find one that works, obviously, and then we might have to come back and do B, the slopey way, the change in Y over change in X way. What do you see happening in C? I see that it goes, oh, you want to do the Y's first? Let's do it. Let's do the Y's first. So on C, if we do the Y's first, it looks like we go up by 3, up by 3, up by 3. What a consistent pattern. Now look at your X's. First one, up by 6. Next one. So we know it's not C. Let's go check D. Do your Y's first. Be consistent, I guess, huh? We'll do the Y's. So -5 to -2 is up 3, up 3, up 3. Things are looking good for D. Let's check the X's. -4 to 0, up by 4, 0 to 5, up 5, it's out. Listen, we just proved that A cannot work, C cannot work, and D. Now, I wanted to show you, by process of elimination, you can now say that it has to be B. Does B look like a linear function? So let me show you proof that it is, and then this lecture is over, and then you can work. We clear? Okay. So here it goes. As we go from one point to the next, and this, I hope you find this to be somewhat interesting. You might not. You're probably done with me by now, but let's see what you think about this. Let's go from this point to this point. What's the change in Y? -2. And what's the change in X? +8, which is a reduced slope of -1/4. Neat, right? Now, that's not, I guess, maybe the neat part, but here's the neat part, I think, because this keeps happening. Take a look at your second 2 points, this one and this one. How much does Y change? -1. And how much does X change? Oh, it's -1/4. Again, neat. It didn't look like a linear function at first, but we're proving that it is. And then finally, let's do the last one, this point and this point. How much does my Y change? -1. And how much does my x change? Isn't that cool? So something that didn't have a really neat kind of pattern to it, turns out, it actually works. So we would pick B on that one. So you guys have any questions? All right, this is what you're doing. It's on the old Delta Math. Let's get her done.